This is the output for lesson 18, the 8 by 8 dot matrix. So as you can see here, we have this entire setup linked to the Arduino. So here we have the matrix itself. So it's all defective. So it's not really fully. Yep, you can see there it's shifting. Some of the things aren't properly loading. But this is all working. The Anyways, so moving on. So we have multiple pins connected to con. Uh, we have them connected to a resistor, and then we have them connected to the input output pins here. Of course, we have the positive and negative charge here, right here, extending through the rail, and then we use that to extend here within the con. The reason why you had this 74HC595 chip is because as you can see, the microchip has it pretty much uses most of its input output pins. So this basically acts as an extension of that, or like somewhat like that. It acts as an extension. So by doing this, we can basically have multiple more we have more input outputs attached to the microcontroller without needing multiple input output pins. So that's pretty much it.
Okay, so for the coding portion of the 8 by 8 dot register Arduino lesson, here we have an array with 8 characters, and here are the different addresses for each of the rows. Here we have an array of different column pins, and then of course you have the different pins for the shift register, the 74HC595. And so for setup, we simply iterate through the different column pins, and then for data pin, clock, and latch, we set them all to output, and then we proceed to the main loop. In the main loop, we set row bits to the first one, to one of the rows. So here we have 0x 80, and then after that we have a nested loop. So we have row, this condition, and then row plus plus. So essentially we're gonna iterate through the rows, and then here we essentially go through each con. We basically go through each column pin, and then we set them to high just to clean them up so that they're all uniform, and then we use write 505 row bits. So we're passing row bits, and the reason why is because this is going to handle the shift register. So the way it works is, think of shift register as kind of a translator, since the Arduino only has 13 pins, and then 8 by the 8 by 8 has like 16-ish pins. And so we're gonna need more. We're gonna use our shift register so that we're able to simply out input and output more data, and make it work within the Arduino's 13 pin mode. So what we do is we first we digital write so the latch pin, and then we set that to low. So the latch pin is part of the con. It's one of the pins within the shift register, and so we simply set as low so that we can like shift it, so we can like set some data. So next we use the shift out. So as it says, we shift out. So we have the data pin, we have the clock pin, and then we have a setup. So this means least significant bit first, and then we have the data. We have the raw data that we're giving out so that it can be shifted out using this configuration. And then after that, once we process that, we simply set lich pin to high so that it executes. And once we prepare that row, we once again iterate through the row, and then we want to use this. You want to use this digital write. So this is to determine which column pin we're on, and then row and so basically what row and this is a shift, and then column. So we shift column by one to the right, and then we compare it with character row. So one of the characters right here, using the row as an index. And so if it's correct, we set it to low, and if not, we set it to high. And so that's how we can kind of iterate through the 8 by 8. And after that, we have a delay of 1 second, and then we set this to low, and then we shift row bits to to 1. And the what call that the shift the ship basically keeps shifting and shifting, so that we're able to basically almost count our way. Is- we can almost like count and iterate through a whole 16 by 16 grid. And so here we have intro, and then it increments, and then it will keep doing that until the entire display is lit up. So that's pretty much it.